All right. Hi, folks. This is Quarkus Inside 93. Max is traveling, so I'm here in his place. And we have, of course, Roberto co-hosting, and we have also Jan and Philip. Jan and Philip, you've been here before. Maybe you want to say a few words about who you are and what you're doing?
Okay, I'll go. I'm Philip. I work mostly in the SmallRye team, so mostly with microprofile stuff. Obviously GraphQL, but also OpenAPI. And I've also done some Quarkus work with DevUI. Yeah.
Yeah.
Okay, hi, my name is Jan. I'm also working mostly on the SmallRye / microprofile stuff, also mostly GraphQL. In my case, it's also mostly GraphQL client side, but also the server side. I've done also things around microprofile metrics and so on.
Cool. Well, GraphQL has been on this podcast before. It was episode 9, so I probably post the link as well. But if you want to say, like, very quickly, why someone should be interested in GraphQL, what you do with it.
Yeah, so I can actually talk about my own experience. I started investigating GraphQL when I experienced the problems with REST, especially if you have a REST endpoint that has got multiple consumers, and every consumer wants something different. So you end up not being able to scale because you end up having this one-to-one relationship with your consumers because they all want something special. So I started looking into ways to solve that and got onto GraphQL, and this whole thing started. So basically, GraphQL is just it's an API technology similar to REST, or actually similar to REST and OpenAPI, because GraphQL gives you a schema and it gives you the execution part. But the big difference is it gives you, as the consumer, the ability to query for things that you want, specifically exactly what you want. And you can combine things and you can filter out things automatically. We'll show obviously some of it today, but today's talk or today's session is not going to be very introductory. We're going to show kind of new features in GraphQL, building on top of the episode 9 and so on. Yeah.
Excellent. Before going there, of course, we forgot to say any Quarkus news. So I think Quarkus 2.10 comes out this week, so look for it. Roberto, do you have anything to say about news?
No, I mean, we're being always putting new stuff in, so just have a look into what's coming new on Quarkus 2.10 and let us know if we're missing something, and we'll more than likely work on that for the next couple of releases.
Yeah. Also, the JNation videos are out. The big part of the team was there. There was a whole Quarkus track. If you're interested in binge watching Quarkus, there is actually one link that has it all. 7 hours of Quarkus talks, but you can find them individually as well. So I pasted there in the chat for you.
Yeah, so right now what you have available is only the entire stream, which basically you have to look for each of the individual sessions on the stream, but our audio and video team is working to have that split. Actually not split, because they actually recorded the sessions individually with a high quality. So now they're just handling all of that work, and we hope to have all of that uploaded as single sessions in the GNation channel, maybe this week or next week, but we'll hope to have that soon. So then people will be able to look forward for each session individually, and they can look exactly what they want.
Mm-hmm. And before even we start, we had a question here. Philip, do you want to fill this?
Yeah. So this came up a few times, and it's probably something that we can look at some point to make this easier. At the moment, I guess the way to do it is to pull in GraphQL Java, or even if you pull in SmallRye GraphQL, it will pull in GraphQL Java. So you always have the underlying GraphQL Java library where you can do schema first. The problem is that you'll still the schema first allows you to provide the schema, but you will still have to write the data binders anyway. So you're going to write some code anyway to match up the schema with where the data comes from. But we'll probably at some point, it's not high on the to-do list. At some point, we will look into making it similar to OpenAPI, where with OpenAPI you can mix and match. So you can either provide just the OpenAPI document and we'll just pull it in and make it available, or you can provide the OpenAPI document and combine it with scanning, and we'll merge the two. So we'll do probably something like that. But at the moment, your only option is to go raw GraphQL Java.
I would like to add that on the client side, we actually have a little bit of some support for schema first. We have an experimental code type-safe client code generator that you feed a schema and you get some code for the client side generated. But that's only on the client side for now.
And that's not in Quarkus, right? That's just in SmallRye.
Yes, right.
Yeah.
Got it. Okay. I think we can go on with the demo. Okay.
Okay, so we have a whole list of things we want to show. I'm going to start off with showing kind of lazy loading and JPA. This also comes up quite a lot because we primarily focus, when we talk about GraphQL, we focus on the transport layer and the savings you get over the transport layer. So saving the overfetch and underfetching problem. So a REST call will make a call to get data. It will return all the data, way too much data. And you'll probably filter it out. And then you might have to do subsequent calls to get more data to actually get everything that you want. And this is typically what we focus on. GraphQL is not concerned about where the data comes from. It just has this ability to get data from wherever, a database, a NoSQL database, another web resource, multiple databases, a file, or a combination of these. So it doesn't concern itself with that. However, because this question comes up quite a lot, I want to show if your data comes from a database and you are using JPA, what your saving is compared to REST. I just want to show it. It obviously is not, it's one data source, and probably you can do something similar with others, but this one will focus on JPA. Right, so before I continue, all my examples is in this GitHub GraphQL experimental. None of it is experimental, but when I started, it was experimental, and I've never renamed it. But there's quite a few examples in there. We're not going to do all of them. I'm going to show some of them. I try and keep them up to date, so it could be a good reference for anybody that's looking for specific examples. I'll probably rename it to GraphQL examples at some point, because most of these are fairly stable and in Quarkus. Some of it is brand new. So for instance, the non-blocking that I'll show is only coming in Quarkus, the next version, 2.10. Okay, so my first example is already running. It's a person object, so we're going to get a person. The actual Pojo is an entity, like I said. I'm using Panache, but it's underneath using JPA. It has some fields on, and the important part here is the collection fields, like either a list collection, which is marked as a lazy loading, or a one-to-many that's also marked as lazy loading, right? So I have quite a few other objects that's pulled in by this model, and they're all marked as lazy loading. And then I've got my log file open, so my server is already running, and the log is clear. And we'll start off with the REST example. So this is a plain old REST example under add path. We'll find person one. So we'll do this part here, and it will return person one in my REST example. So I've got it up and running on 8081, and we want to go to Swagger UI and try out person one. So what I also have is I have SQL logging on. So it will show what Hibernate does in the background. So, right, I can get all the data. Here's all the data. It's quite a lot because, it pulls in all that data. But here's what Hibernate did in the background, right, with my Hibernate logging on. So this goes up quite a long way, right? So it found the person, and then it started going through all these lazy loading relationships. And it did that because it doesn't matter that it's lazy loading, because I need to send it over the HTTP. It eventually needs to get those lazy fields. So if we do the same with GraphQL, but this time we can ask what we want. So let's go back here and go to GraphQL UI. So now if I say get me person, and this time I'll just get person 2 because of second level caching. But I only want the title and the surname as an example. Right, so now I only get that back. So you can see the saving over the network. But if you look at what did Hibernate do, you can see that this is also much less work on the Hibernate side, because I didn't ask for any field that was lazy loaded, so it wasn't loaded. Right, so that's already a saving on the back end if you use lazy loading. Now, it still went and fetched all the fields. So if you want to go further and actually cherry pick specific columns, you can do that as well with the context object. It's not pretty, and it's probably something we can make easier to use. I am not convinced of the saving. I think if you have like thousands of columns in your table, then probably you'll get a saving. But for normal database case, I'm not sure if selecting these two fields versus these fields is that big of a saving. But just to show what you can do, if I go to my backend service, so I'll just rename this one to get person 2, and we're going to work with this one now. So this one was the one that I've shown now, which just does a find all, right? So this is a plain JPA Panache query. With this one, I'm going to inject the context, which is an object from GraphQL. It hasn't moved up to the spec yet, but it will at some point. So this comes from SmallRye.
Can you increase the size of the font?
Yeah, sorry.
Thanks.
I don't know what. Yeah, thanks. Right, and what I do here is I basically get the selected fields of the context, because the context gives me the selected fields and a few other things that you can get. And this is downstream. This is not inside my GraphQL API. So anywhere downstream from your API, you can inject this context object. You can get the selected fields or some other stuff as well. And here I'm just basically going through the selected fields, and then I build up a query manually, and then return the result. So if I save this, I should be able to now do, let me clear my log file a bit. So if I do this again, Quarkus should restart, and now my Hibernate is even smaller, the work that it does. Right, so that's your two kind of options at the moment with JPA. Context, obviously, you can do outside of JPA as well, because if your backend has a way for you to kind of select these columns, you can get what columns has been asked. So that was the first thing that I wanted to show, lazy loading in JPA. Maybe if there's any questions, we can take them before we move on.
There is one, Philip, about authentication. I'm not sure if you don't want to talk about this after or.
We're going to show authentication a bit later, so we can either talk about it now, or we can just wait a bit, because we should get to that, I hope.
Let's wait a bit, no problem. Yeah.
Well, I'll post a couple of questions to you regarding this example. So since JPA definitely and Hibernate is definitely a very popular technology, and we know a lot of people use it now. And this GraphQL example with Hibernate is really great. Now, what will be your recommendation when using GraphQL and Hibernate on how you specify the lazy loading of your relationships? Will you recommend to have eager stuff? I mean, we know that some people will put some eager stuff and even do left joins on their queries to grab some data beforehand. Yeah. But with this style of usage, what will be your recommendation how to set up your entities in that case?
Yeah, because you wouldn't know how your clients are going to use this, or you might not know how your clients are going to use it. So your safest bet would be lazy loading everything. Now that might in certain cases not be ideal. So if you if you know how your clients are going to use it, then you can probably optimize, and certain things will be eager and others won't be. But if you don't know, I would just go with lazy all the way, and let the client decide, because I think your saving in the big run, in the bigger picture, will be better. But I don't know. I actually don't have the answer. The other option that you potentially could look at is criteria builder. But I don't have an example on that. But that in conjunction with context could probably give you something in between what I've shown now. I don't know if that answers the question, but yeah.
I see. Well, thanks. I mean, it still helps, right?
Yeah. Okay, I'm going to move on to the next example, which is a non-blocking example. So, like I said, with 2.10, we've added proper support for non-blocking. Now, if I say proper support, we previously supported the constructs of mutiny. So you could have a response type that responds with a uni, but it will always still execute it. It will always still execute on the worker thread. What we fixed now is that this is actually executing on the event loop, and we support the non-blocking and blocking annotations and a mix of those. So in my example, in this example, it's a pretty boring endpoint that just prints the thread info. So I have a few queries. This one just returns a plain object. So the rule will be a plain object will run on the worker thread. A uni, like this one here, will run on the event loop. Or you can dictate the behavior with annotations. So if you have a normal object, but you annotate it with non-blocking, it will run on the event loop. And for some reason, if you want to do this, you can also make a uni blocking. Right. And then you can go further into source fields. So a source field is something that allows you to kind of stitch things onto your response that might not be on the Java object, but you want to add it to the GraphQL object. So in this case, the same behavior will be here. So this is just a normal object, which means this will run on the worker thread. So I'll show the example and see if this is clearer. So that is this one. So we'll start with thread info, and for now we'll probably just care about the name, because that's the only thing that matters. So you can see that this runs on a worker thread. I can also do, like I showed, a uni, and the name now will be the event loop. And then the same with the blocking and the non-blocking. So if I mark a normal object as non-blocking, then it will switch to the event loop. And if I do a uni and I mark it as blocking, it will switch to the worker thread. And you can see that all of this is really one request. And it still runs, even with that one request, it will pass the context along, and it will mix and match. The other interesting thing is that I've added a thread info on a thread info. So I've got this kind of infinitive loop here where I can now say, I'll also get me the thread info child on this guy, and give me the name of that. So this should be, let's take this out just to make it simpler. So this will both run on the worker, but if I make this a uni, then this will be on the event loop and this will be worker. And this is passing context from here to here. So when I say context, I mean that context that I've shown you in the previous example, that will propagate properly, but also your own request scope context will propagate properly. And then any combination of this will work. So if I do this, but I do this, then this will still work. And obviously, in this case, you can go even deeper into the graph. Right. So that's non-blocking. Let's see. Is there any questions around non-blocking before we move on? Nothing.
Not really about non-blocking. There's one about federation, but I'm not sure if it's
Oh,
to this part.
let's do the. Can you please comment about schema stitching a poly federation using GraphQL API and your services is likely to be joined somehow? Right. So, federation, we don't have proper support in Quarkus yet. We started playing with it in SmallRye, and there's a part where we want to allow our services to take part in federation automatically, and then probably take part using some sort of a annotation. But we still need to do some work on federation to, so that it's worked properly. So for me, that's the big thing on my to-do list for GraphQL next is federation. But I obviously spread this workload with a bunch of other things that I'm doing. So I'm not sure when we'll get to it, but that's definitely something we'll look at next. So maybe in the next Insight, I can demo federation.
Cool.
Right, so let's move on to the next thing that I want to show is adapters and map support. So if you know JSON-B or any JSON, I guess any JSON parser, all of them has some sort of a adapter, a way to adapt one object to another object when you go from JSON to object and vice versa. So in this example, we want to try and do the same. So what we have here in person here. Okay, so we have a few things that we can do with adaptation. We can adapt to a scalar. So you can adapt one scalar to another scalar. So if we look at this one, this is an int. And if we look at the example here, a query, no, this is not the right example, adapter docs. So query person, you'll see that this is marked as an int in the schema. But if you want to make it something else, like a string, then you can do that by just doing that. So any scalar to scalar mapping should just work out of the box like this. We have the mappings between the scalars so that they map. Obviously, if you go out of bounds, so if you take an int or you take a long and you mark it as an int and it comes in as a out of bounds for int scope, then you'll get a runtime error. But so you need to use it safely. But so this should already change that schema. If I refresh here to an error. Scalar.class. No, this is wrong. Sorry. Scalar.string.class. Sorry. Come on. Okay. Right. So this should fix that. So now if I look at person, my ID is a string. And obviously when I use it, it will be it will also handle that. So that's the first option that we've actually had for a while. And that same one, adapt to scalar, you can also adapt an object to a scalar. So something like a phone object, like this, you can mark as a scalar. Now that's typically useful. Let me actually show an example. I haven't saved yet. So if I do person with ID 1, and we'll just get the surname and the phone. And at this point, the phone, maybe it's already phone numbers. Yeah, maybe it's already saved that. So let's save that like that. Yeah, so at this point, the phone number is a complex object itself, right? And maybe you know that you can actually flatten this to just that. Then you can do something like this where you say, don't create a phone object in my schema, just use this and take it to a string. And the way in which it works, so this will now, if I refresh here, you'll see I get an error because phone number is now a flat object. It's now a scalar, right? And it shows me this, and this is because in my actual phone object, my toString does that, right? So my toString prints it out like that. So we'll use the toString, and when you use it as an input, so let's say you can mutate a person, you can do things like either a static from string or a constructor that takes a string. So the type, the scholar to which you adapt to needs to be in the constructor or in a from string, and then it will happen automatically. What we've added apart from this way then is the third option, which is now adapt with. So if we look at address at the moment, address, it has lines and it has a code. So at the moment, address looks something like this, right? And a code. So if we know that our addresses are properly formatted and we actually want to create a proper queryable object out of this, we can now say adapt this address using the adapter. Now this is basically copied from JSONB, and actually you can use JSONB here as well. And then you use an adapter to say, how do I get, where's my adapter? How do I get to and from, address and home? Right, so now I can define a new object, home, which doesn't contain a string list of lines. It actually has more insight into what this is. So if I do that, save, you can see that now I have insight. So now I can say I actually only want the city back. Right. So anyway, the bottom line is it gives you the opportunity to map an object from one to the other, and it will also clean up your schema. So you'll see that address shouldn't be in the schema here. It'll only be home, right? There's no address because we know that it's not used. It's only used on the Java side. Now, on top of that, so once we had this functionality and we added this, we then built some built-in adapters. And one of them is a map. Right, so in the next example, which is map example, just close some of this. So this is a language endpoint, and I now return a map. Now this wasn't previously possible with GraphQL, but we've added support for map because it's a popular construct in Java. There's no such thing as a map in GraphQL because a map is not really queryable in terms of understanding what is in that map, because I can have a map and in runtime I can add a field name called name and the value is Phillip, and a field called surname and the value is Krüger, and I can't tell you that in GraphQL, okay, you can query the name, right? So it's not a nice thing to use when you want to build a queryable API, but we've added support for it with this underlying adapter technology that we now have, right? So we can adapt things. So we've got a built-in map adapter. So by default, if I go to map example, so I can then say, give me the language, and then I have a key and a value. So we basically treat it as a list of key value pairs. And obviously, if the value is an object, you can go deeper into the object. So I can here say, give me the please and the thank you, right? So then I get the map back. What we also added to map by default is the ability to query by key then. So in my case, my key is an enum, so we can actually tell you, right? You can use the language that you want. And then you can do something like this, where you say politeness, and then please and thank you, right? So now you get only that key back. So that's built in by now. You can also overwrite map support by providing your own adapter, like I've shown you the adapters just now. If you have your own map adapter, we will ignore our built-in one and use yours. Right, so that's maps and adapters. Is there any questions on that?
I don't see any question, and we're halfway through the hour, so.
Ish. Okay.
Yeah,
so
I'll give you a question about it. So you did mention that you could use that with JSONB as well. Can you elaborate on that?
Yeah, so for most things that we do in GraphQL, if there's something similar in JSONB, we added support for JSONB for that as well. So we would, for instance, have a name annotation where you can decide to name your query either by doing this, give it a name here, or just name it like this. Right. But if your object is already using, you're already using that same object to marshal to JSON B, and you're using JSON B, and because it's part of the same microprofile spec, we support that as well. So if you here say add JSON B property, maybe not here, maybe on the actual Pojo, right? So like on here somewhere, we will also use that to name your field differently. So properties, ignore, what else? Yeah,
Transient.
Adapters, transient, all of that is supported from a JSON B, and some Jackson as well. I can't remember off by, I'll have to go check what Jacksons ones we support as well. We try and support both the Jackson and the JSON B. The spec will probably always only reference the JSON B ones because of they're part of the same umbrella. But cool. So I think next is Jan that's going to show some stuff.
Yeah, I'll show you one of the new things that we have added lately, and that is bean validation directives. So you probably know you can use bean validation annotations on your GraphQL endpoints. Here in this example that I'm showing, we have a mutation for rating movies. It is an operation named rate. It takes an ID of the film that you want to submit a rating for, and a double that actually is the rating value. Well, and of course, we want to limit that somehow. We want to only accept ratings between 0 and 10. So we use bean validation annotations. So we have two annotations, one for the minimum value, one for the maximum value. And well, this has been supported for quite some time, but what we have added recently, I think that's since Quarkus 2.9, I think, is that when you use these annotations and you enable the directives in the schema, which is by adding this SmallRye GraphQL schema include directives equals true property, you will get GraphQL directives now generated from these annotations. Now, what are our GraphQL directives? I will show you right now. I will get the schema of this service, and hold on. Yes, here I will find the rate. Yeah, so this is the schema. Here you see the definition of the rate mutation. You see that the rate mutation gets the ID. It also gets the key. That's not important right now because that's added because it returns a map. And there's the rating. And on the rating, you only see not only that it accepts a float GraphQL type, you also see these constraints. Now, these are directives. These are directives are some additional metadata that can be included in the GraphQL schema that convey some additional information about the elements included in the schema. So in this case, you can see that the rating has to be between 0 and 10 for each bean validation annotation. We transform it into a constraint directive. So client applications can immediately see that there are some additional constraints placed on the arguments of the rate mutation. So, and if I don't know, try to rate a movie with this ID, I'm not sure what this movie is. I think it's Top Gun Maverick. I'll try to rate it -7. You will see that, yeah, that the operation doesn't go through because the rating is too low. Okay, so these are bean validation directives. Another thing that I want to show you is subscriptions. I have subscriptions. Yeah, subscriptions that are basically a special type of operation that is not like compared to queries and mutations. It's something that returns multiple results, not just one result. with a query and mutation, you send one request, and get back one result. With a subscription, you send a specification of what type of events you want to receive and you start a WebSocket connection to the server. And over that WebSocket, you get multiple events when something happens. So, like in our case, we have a subscription operation for that you can use to receive notifications when a movie is rated. So, for example, we'll show here. I will start this subscription. You see, it's a subscription. It's named "Listen for Rate Changes," and this means I just initialize the connection. I initialize the WebSocket, and this means that when a new rating for a movie arrives, I will receive a notification about it. The WebSocket stays open for as long as you need, and you will, anytime a new rating appears, it will appear in this UI. So if I now rate this same movie, I think it's Top Gun Maverick, I'll rate it 5. And the rating mutation itself returns all the known ratings of that movie. So I set the rating from the Quarkus community to 5, and there are other sources of ratings like IMDb, Metacritic, and they have different kinds of different numbers. So I rated this movie with 5. And if I switch back to the original tab where I have the subscription running, you see that I have received an event about a notification about changing about the new rating. I decided to receive when a new rating appears. I decided to receive the ID of the film and the rating from the Quarkus community and from Metacritic, which I can remove. It's not important right now. So, yeah, if I do another rating, like I saw it again, I do 8, and then I receive another notification about for a rating change, and this time the rating given by the Quarkus community is 8. I will now show how subscriptions work with the client library, because here I've been using GraphQL using the UI manually, but we of course have the client-side library. I will show you that. I have an application. Yeah, by the way, in the upper terminal, I have the server-side application running. In the lower terminal, I have the client-side application. So the server side will handle the ratings and so on, and the client side will be the one subscribing for notifications. So and the client side is a CLI application, so I will tell I want to use GraphQL. I will want to receive notifications about new ratings. So now what I just did is that the client-side application started a subscription, and will now anytime I change a rating for a film, it should appear here in the log. Let's just give it a try. Rate this movie with 4. Run it.
Hey Jan, I'm sorry. Some people are saying that your screen share is frozen. Maybe you can restart the screen share to see if it makes it better.
Restart the screen share. I can try.
Sorry about that.
Is it better now?
We'll see. Well, for us, it was always okay, but
okay.
I'm not sure about the people in the stream. So let's see. Do a couple of things there and see if the people on the stream is able
Yeah.
Can
Yeah.
you confirm if it's okay?
Yeah. Now, can you see my IDE now?
Yeah, we can.
Okay, so I just wanted to briefly show how the code, how this works on the client side. I'm using the GraphQL dynamic client. That's the type of client where you build queries or GraphQL documents using a DSL, and this is how you build a request to start a subscription. You create an operation of type subscription. The name of the subscription is listen for rate changes, and these are the fields that you request to receive on every event. And then you use a dynamic client instance to start a subscription from this specification and subscribe. In this case, what I do when I receive a new item, I just print it into the log, new ratings and the contents of the event. So in this case, you see that I received a notification that somebody in the Quarkus community decided to give that movie a rating of 4. Okay, that's about subscriptions. If there are no more issues or questions, if not, I will move on to another thing that is SmallRye Stork. You might have heard about SmallRye Stork. There was a Quarkus Insights about it. It's episode number 70. And so I will quickly tell that SmallRye Stork is a library integrated in Quarkus that allows you to connect to various kinds of service discovery providers like Kubernetes, Consul, Eureka, and more. So it's used for client-side applications like REST clients, and now also GraphQL clients, and allows these applications to find the remote service using a service discovery mechanisms. So yes, I will show how to use it. Basically, normally you would configure a GraphQL client by specifying a URL like this one. In my case, it's a simple localhost. If you want to use Stork to go through some sort of service discovery, you instead specify the URL. I will comment this out and uncomment this line where the URL, I will be using the Stork schema in it, and I will be connecting to a Stork service named my service. And I will also add the configuration of my service. In this case, for the demo purposes, I won't be using any complicated Kubernetes stuff or anything. I will just use a static list of addresses. And so the type is static, and the address list is just one address, and it's the local host, that's the server side. So if I just do this, the client will work still the same way. It will just, when discovering where to connect, it will go through Stork. So if I just run it again, and I specify that I want to, again, start a new subscription, and I will add a new rating. It just works the same way, but yeah, it went through Stork. So yeah, and now I will, unless there are questions or anything, let's switch back to Philip. Yes.
It's maybe, I don't know, I don't think you've mentioned it, but it's maybe worth it to mention that for subscriptions, we actually support a spec. You didn't show that, did you?
Yeah, right. We support the GraphQL over WebSocket protocol. This is the GitHub repository. If you're interested in this protocol, this is the specification of that protocol. And we support this one. And we also support one of the older ones, the Apollo protocol, We support both, and the client and the server understands both by default, and it's on the client to decide which protocol you want to use.
And you can also do queries and mutations over WebSockets, so you don't have to use plain HTTP.
Yes.
You can,
This also supports single result operations. Yes.
Yeah. And it's also worth mentioning that even for HTTP, so the usage of GraphQL over HTTP, we conform to a spec. And it's actually all documented on the GitHub README of SmallRye. But it's not our own stuff. We conform to that specific spec that defines how GraphQL will work over HTTP. Okay, cool. So we can maybe, if there's no questions, move on to the next one that I want to show, which is also something that comes up quite often, and that is the N+1 problem, which sounds worse than it really is. It's really just in the case of something like this, like people. So I'm getting people back, and then I have this source field that gets the exchange rate for that person. Now, if I have 100 people in my database, I will go and call the data fetcher for this exchange rate 100 times. And we can actually show it here. So here's my log file. Here's my example. So plain GraphQL endpoint, I inject my two services, person and exchange rate, and then I marry up exchange rate to person by using the source annotation. And you'll see that I print out here, when I go make a backend call, I just print out making a backend call. So if I do this, and there's 6 people in my database, I'm making that call 6 times, which is obviously not efficient. So that's the N+1 problem. To solve it, all you have to do is something like this. So the difference here is that I'm not passing in a person as my source. I'm passing in a list of people. Now, this will work even if you are just asking for one person. But in the case that you are returning a collection, this will be more efficient, because what it will expect as an output is a list of exchange rates. So now you can efficiently, rather than calling the backend only every time, you can decide how to handle the list of people and batch it, send that batch to your backend. So if I do this and I clear the log a bit, and I do this again, I've now only called that backend once, so it's just more efficient. So that's batching. Is there any questions on batching? Nothing. The next thing, we're running out of time, but we got to security, which was the one question. Am I still on? Yeah. Am I still on? What's happening? Okay. Sorry, it's giving me some pop-up message here. Okay. Okay, cool. So the security example, that I want to show, what I've done now is I have an endpoint again. I'm using the same one over and over, with the difference being that I'm now saying that you have to be a user to get a person, and you have to be admin to get exchange rate. And then I've also added in my POM, I've added OpenID Connect, right? So, and using dev services, it spin up Keycloak for me. So now if I go to the next example, which is the security example, you will see that I have Keycloak here. But if I go to my GraphQL again, and I now say, get me a person and get me the title and the surname and the exchange rates, and maybe only the rate. Oh, and I must maybe say what person I want.
Philip, maybe we do the trick again and reshare, because we get some report is frozen. Sorry.
Okay, I've reshared. See if that's better. I got some error on my screen here. It looks, yeah. Anyway, yeah. Let me know if this is better.
Go ahead.
Okay, so when I do this now, because it needs to be secured, I'm just getting an unauthorized exception because I'm not authorized. So if I go back here and I go to my dev services keycloak and I log in as Bob, then you'll see that Bob has got user access, right? And what we've done is we've actually embedded a link for you here. So if you have GraphQL, we will add this link here. If you have Swagger UI, we'll add the link here, and it will just take you to Swagger UI logged in, and you'll see that it basically just adds the header, the bearer token. But if I do this now, I can get the person back because I'm a user. I'm not admin, so I can't get the exchange rate. So I still get a forbidden on exchange rate, but I can get partial results back. So if I go back here and I log out, and I now log in as Alice, you'll see that Alice has got admin and user rights. So if I then go back to GraphQL and I run this again, so still this is here, but now I can get everything back. So that's kind of security very quickly. Back to Jan.
Right.
If there's questions. No.
Nope. No. Yeah, I just, for me, there's just one thing remaining that I wanted to show you, and that's the support for Java records. Yeah. So basically, for the domain classes that represent your GraphQL types, you can now use Java records because we're up to date with the latest Java versions, right? What didn't work before but now does is if I have a class movie ratings. Yeah, that's basically the class that we've been using for my examples, that contains the ID and a set of ratings. I can now transform that into a record with that has the same fields of same names and types, and it will just work. That didn't work before, but now we fixed that, and it will just work the same way. So that's quite convenient. Yeah. Yes. Okay, that's it.
Okay, we have some time still, and we have two things we prepared to show, or else if there's questions, we can maybe field that rather. I can't see the questions anymore since this.
I don't see questions either, Philip. So I think we can keep going for 5
Okay.
minutes, maybe.
Okay, so the next thing that I wanted to show was support for generics, which we've also added since episode 9. So you can now use generics, and we will create a value in the schema for you and allow you to query it. So in my example, I've changed my endpoint to also include aliens and not people. And this being basically takes a generic type. And now I can pass in person or alien. And then in here, I can now ask for person, and then I can get the being back. And now I get an actual person back. So I can get names or whatever, surname. But I can also then ask for, person one. I can also ask for aliens. And now my being is an alien. So the from, I keep on forgetting passing the ID in. The from and the type as an example, right? And if you look at the schema, we basically created with this underscore in between. So even if you go look at the map example, the map underneath creates a list, a generic list of key and value. So if you look at the schema, you'll see that we actually created in there as well. So that's support for generics. If there's no questions on that, we can actually finish.
There's 2 questions. So one is on board. Look at it.
Yeah, so this on the security one, you can do it on source fields, not on fields. Same with REST. You can't do it on REST either. So on a POJO field, if you have a person, that specific field you can't do. If you want to do that specific field, you'll have to move it to a source field, because we only do it on operation level, right? So we only do it on, let me go back to my security example. Yeah, we only do it on this level here. So I can do it on a query, or I can do it on a source, or I can do it on any operation level. I can't go and add it here. And this is true for REST as well, right? I can't go and say you can't see ID. So that should answer that question. What's the other one? Also, is there any support for plans for file uploads? No, there's no support at no plans at the moment. I don't even know how that would work. Because a binary is not a queryable object, really. I'm not sure if it makes sense. Maybe it does. I don't know. I haven't thought of that. So if you want something, definitely start a discussion on the SmallRye discussion group. So let's do. We have 3 minutes. Let's do paging quickly, because that also comes up quite a lot, and that's actually also something that's pretty high on the to-do list for us, apart from federation, like I've mentioned. So I wanted to show how you can do paging manually at the moment already. And there's various ways in which you can, strategies you can use. In my example, I just said, let's say how many items is on a page and what page number there is. So if I use this example, so you'll see that I've just added 2 input parameters. Because they're objects, they are optional. And then now if I ask for people like normally, it'll still return all the people. But I now have the ability to say, okay, give me 2 people per page and show me page number 1. And then it will do those 2. And then I also have a way to then say, okay, get me the page info and maybe get me the next page number and tell me if it's the last page. There's all sorts of page info in there. But now I can know, okay, the next page number is 2. So now I page to 2, and then I page to 3. This is one strategy, and this is the more generic strategy that will probably somehow build in with the annotation that we automatically take care of this. So you'll just say, make this pageable, like add pageable, and we will page your collection. And that's all the stuff that we wanted to show. I know it was quite a lot. If there's any more questions, we can take that. We have 2 minutes.
I think we're good. There is some chatter, but I think it's not a straight question. Anything else? Jan, Philip, Roberto, I think.
That's been a great presentation, in my opinion. I think you showed really, both of you showed really interesting use cases, and I hope that people that are using GraphQL can now move forward with some of these as well.
I just hope Antonio are now interested in GraphQL after this session.
All right. People are asking about
the link to the repo.
Yeah.
Let me find it quickly. It's just my GitHub. It's GitHub. And it is experimental, this one. So like I said, it's not really experimental anymore, but yeah, it started off being experimental features. I continuously add to this as I have small use cases that I want to demo. And Jan's one, I think, will be the JNation demo, right? So it's just
Yeah. I basically recycled the application that we used on our JNation presentation.
Yeah.
All right, excellent. I think we're good for today. Thanks very much, everyone, for staying with us.
Thanks.
See you next week.
See you next time.
Bye-bye.
Bye.